Now, as we start Chapter 4, there's only 2 topics in this, and you've had your quiz. We're now going to do some more intensive review, and hopefully with this drill you'll be successful in earning your mastery. But as we look at the graphs once again, there's a couple of things that can happen. For instance, if we drew a line, which is a graph, something like this red line, and then changing colors here, get a blue, and had a line that went this way, we can say something about this point of intersection right here. And at this point, remember there's an infinite number of ordered pairs along each line. But out of all those infinite number of pairs, there's a unique pair right there that is going to be a solution for this equation, which shows positive slope, and this equation, which shows negative slope. Now, when we do this by graphing, and we end up with this ordered pair, we have solved these systems of linear equations simultaneously. And the technique we used was graphing. So we'll be using the skill of graphing from Chapter 3 to solve some of these equations. Now, as we look at this graph, and if we were to draw a line, this is positive slope, and if we drew another line, and I'll change colors again here, what can you say about this? Well, you could say that, again, along this blue line, there's an infinite number of ordered pairs, and along this red line, there's an infinite number of ordered pairs, but there will never be a common ordered pair between the two, because these lines would never intersect. These are parallel lines. Now you might recall from the previous lesson we said the slope of one is equal to the slope of the other, but now we know the y-intercepts do not equal each other. So this is a little carryover from Chapter 3. Now another scenario might be you draw a line, again this is positive slope, and then you have another equation and you did everything properly, you made a t-chart or you put it in slope-intercept form, and when you went to plot the other, actually they were right on top of one another. In fact, they're the same equation, maybe disguised. One might have been in standard form, the other in slope-intercept form. Or, for some reason they look differently. When you graph them, they were the same. So again, there's an infinite number of ordered pairs for each equation, but they're going to be the same because it's the same line. So we say there's an infinite number of solutions for something like this, where one line is imposed on the other same line. Here there are no solutions, and here there's just this one unique solution of where they intersect. So this is the background of what we'll be doing in Chapter 4, and particularly Section 1. Now the first thing they want us to do here is to see whether or not these ordered pairs that are listed below here, we can raise it up now a little bit, have a common solution. And we solve this by seeing whether or not this ordered pair is a solution for this equation and a solution for this equation. So what we want you to do is to put these values, this for the x, this for the y, into these equations and see if they make a true statement. And I'll be doing them here as well. So this first one will be 3 plus 1. 3 plus y, 1, is equal to 4. And that checks. That does equal 4. And here this is 3 minus the 1. Does that equal 2? Yes. So this is where, if you were to sketch these two equations, they would intersect. All right, and looking at letter B now. Here we're saying that y is 4. Well, y is 4 there. So that is true. And then here we're saying x is a -6. And then a -3 times 4. Is that going to be a -6? No, that's a -12. So this would be a no. This one is going to be a yes. And then here we're going to put these in there and we're going to see if in fact that's true or not. And hopefully you've gotten some results. So 2 times our x value, which is 1/2, plus 3 for the y value, is that equal 4? Well, 1/2 of 2 is 1. 1 plus 3 is 4. So this checks. Now here this is going to be a -3 times 1/2. Does that equal 2 times 3, which is our y value, plus 8? Well, this becomes a -3/2, and this becomes 6 plus 8 is 14. No, this doesn't equal. So this would be a no. All right, these will be things that you might use as you check your work to see if the ordered pair you get from graphing or other ways to solve it is in fact a solution for both equations. Now for example 2, and you should have some graph paper somewhere, we'd like you to solve these systems of equations by graphing. So we'll raise this up a little bit so we can include the graphs. And you might say, well, what system might I use to solve this? Well, they're both in standard form here. So I would suggest making a t-chart. That x and y intercept t-chart that we used in Chapter 3. And we'll give you some time. Now, this one, you could use the x and y intercept t-chart, but you're going to get not really, because 4 doesn't go into 10 evenly. And again, these are all going to be fractions. So we may have to solve these for y so that when we plot them, it'll be a little easier. Now here, this is in slope-intercept. This is in standard form. So we could plot it directly from this. This one we may have to solve for y. All right, we'll give you some time to work on this. Now in doing letter A, if x is 0, y is 4, right there, and if y is 0, x is 4. So we have a y-intercept there, and this is our graph of it. I'm just looking for the point of intersection. Of course, it extends beyond that. And this one, if x is 0, y is going to be a negative 2, which is right there. And then if y is 0, x is 2, right there. And I extend it, and it intersects right there. And if you could read it carefully, it would be 3, 1. Okay, so this one was relatively easy to do. And let's see this one here. Well, converting these into slope-intercept didn't help me out too much, because these y-intercepts are rather interesting here. But let's see what we could do. So we, again, transpose the 2x to this side, got a negative 2x, divided everything by 4. So 2 divided by 4 is 1/2, negative 1/2. And then 10 divided by 4 is 5/2, which is 2.5, converting that. So to plot this one, just to go over that little technique here, we're going to put a dot, and on your math lab, normally they give you a split screen. There's a 2.5 for our y-intercept, and our slope is going to be a negative 1/2. So we're going to go over 2 and then up 1. So we're going to go over 2 and down 1 here, and over 2 and down 1. I'm just getting some more points here to make my line. And again, on MATLAB you can do it so much better here. So this line's going to be something, and I got to do it a little higher than that here. All right, I'm going to take some time to do it here instead of doing it live. Okay, it took me a little time to do this. So we got the one in red here. There's our y-intercept 2.5. Now our y-intercept for this one is 3 1/3, which is right there. Then I went over 3, up 4, there's my second point. And when I carefully drew my line, I see my point of intersection now. What do you guys make it out to be? Well, how about a 1, 2? And that matches. Okay, so this one might be a little easier because it's a -1 slope with a 3 y-intercept here. So 1, 2, 3. And a -1 slope. That means it's going to go over 1, up 1. And it's going to come down here to 3. So let me put that line in carefully. Okay. And then when I do this next one here, let's get some a y-intercept t-chart going. I think will work for this a little bit anyway. Let's see, we're going to have if x is 0, y is going to be a negative 1/2. And if x is 0, well, if x is 0 here, this is going to be a negative 1/2 again. So let's put them in there. Negative 1/2, negative 1/2. We take a little time to do that here. Okay, so after carefully plotting these, and it was kind of jammed up there, that x is a negative 1/2, 0 is right there, and then the y-intercept is right there, and if I make the lines, these are parallel. So, will they ever intersect? And the answer is no. So there, for this, there is no solution. In a sense, it's an empty set. There's no solutions. Okay. Now, the graphing method can be rather challenging. Again, when you're using MATLAB, it's a little easier because the lines are so precise. But here, a little bit this way or that way throws you off. So other methods for solving equations are available. And there's two that we're going to look at today, and you may know already, is substitution, and then later elimination. So let's look at substitution and what's involved. Well, the key is you first take one of these equations and solve for either x or y. So let's solve for x. X is going to equal, transpose the y, a negative y plus 4. We're just taking this y and moving it to the other side. Now you could move it after the 4 as well, but I like to do it this way. Now we know what x is. We're saying that x is this value. So then we take what we know x to be and put it in the other equation. So we're saying x is a negative y plus 4 minus y, which is still in the equation, equals 2. We group like terms. We get a negative 2y. We're going to take our plus 4 and move it to the other side, where it becomes a negative 4. So 2 and a negative 4 is a negative 2. We're now going to divide both sides by a negative 2. And we get y equals 1. So of our ordered pair, we now have one member. We're saying y is a 1. Well, if y is a 1, we then put that 1 in either equation, and we'll say x plus 1, this is our y that we're replacing there, equals 4. And then now x equals, transpose the 1, becomes a negative 1, or subtract 1 from both sides. This is 3. And this is our ordered pair. And it is a solution for both of these, because we did that one earlier, believe it or not. All right, now looking at this, you might say I have fractions here. Well, the key when you have fractions, get rid of the fractions. You're going to multiply each term by 4. And when you do so, you get these 4's cancel out here. And you get x plus y equals 8. Now, you can solve this equation for either x or y, or you could solve this equation for either x or y. If we did this one, this would be x equals, transpose the y, y plus 2. So we know now that x equals y plus 2. We take this, substitute it in the other equation. This is y plus 2 plus y equals 8. So we get 2y, and we're going to subtract 2 from both sides, equals 6. Divide both sides by 2. We get y equals 3. We now have a member of our ordered pair. Well, if y is 3, and you can use either equation, this one here, for instance, x plus 3 equals 8. We're going to subtract 3 from both sides, and we get x equals 5. And there's our solution. Now, as we go on to letter C, we're looking, this is in slope-intercept form. So here is what y is. So we're going to rewrite 12x plus 4, our value of y that we're going to substitute, put it in parentheses, a negative 3x plus 8 equals 32. So again, we're using the substitution method where we solve for one letter and then substitute that value in the other equation. Y is this. So we clear parentheses, 12x minus 4 times a negative 3 is 12x. 4 times 8 is 32 equals 32. Notice what happens. This cancels out and we get 32 equals 32. Now, when that happens, and you see that your letters eliminate, and you get a true statement, this is a situation where the graphs are going to be right on top of each other. So these are actually the same equations, this in slope-intercept form, this in standard form. So what is the solution for this? Well, we say there's an infinite number of solutions, and we usually write it using what is called set builder notation from earlier. X comma y is such, and you just give one of the equations, and that indicates that they're the same equations. Now you could also have used the other one, x comma y is such that this. And that's how these are done. Now, another method for solving equations using algebra is what is called the elimination method. I don't know why I get those big things there every once in a while. I only want to use a small line. There we go. So what is the elimination method? Well, what we do is line the equations up in standard form, and then in this case we put a line underneath them and see if just adding them up will cause one of the letters to be eliminated. So here we're going to get 2x. Here these are eliminated through subtraction, and we get 6. So x equals 3. Well, we have one of the members. So if x is 3, let's put it right there, x is 3 plus y equals 4, what will y be? Well, y, when we subtract 3 from both sides, or transpose that, will be a 1. So this is like super easy when already by putting a line something will cancel out. Now as we look here, again we're looking to see if something will cancel out. And no. So what do we need to do? Well, we need to study them a little bit. And here I have a negative 6y, and here I have a negative 6y. If I multiply this top equation by a negative 1, that will make this a negative 1. That will make this one a positive 6, and this will make this a positive 9. I'm just changing all the signs by multiplying each term by a negative 1. Notice what I've done. I've made it so one of the terms will cancel out. So now when I add a negative 1x and a positive 8x, I get 7x. These canceled out, and now I get a positive 9 and a negative 30 gives me a negative 21. I'm going to divide both sides by 7, and I get x equals a negative 3. So I have one of my terms now. And I can use either equation here. Let's use this one. So if x, now we use the original, which was x minus 6y equals a negative 9. So my x is going to be a negative 3 here. And I'm going to transpose that to the other side, where I get then negative 6y equals, on this side this became a positive 3, so this was a negative 6, and now I divide both sides by a negative 6. Here these cancel out, and I get a positive y equals 1. So I had my x value there. I didn't mean to close that parenthesis. Let's see here. So, comma 1. And if I were to put these into these original equations, they would make it a true statement. But again, the method I used to solve it was the elimination method, by getting one of the equations to have something that will cancel out with the other. All right, let's clear this up here a little. So I've copied these two equations for letter C over here, because I want to, again, model this for you of how to solve something like this. They're both in standard form, but after studying them, nothing's going to cancel out as they are. But if I modify this equation somehow, so this becomes a 6x, these will cancel out. So this is how we do it. We put a little bracket and we put a 6 out here, because we're going to multiply each term by 6. And the way I'd like you to show this, and later on your blue sheets, is the way I'm modeling this for you right now. So this will become 6x minus 24y equals a negative 48 here. Now, this equation doesn't need to change at all, so I'm just using this arrow to indicate this will be a negative 6x. This is going to be a negative 3y. And this is going to be a negative 6. So now when I draw my line, these will cancel out. And I'm left here with a negative 27y equals a negative 54. Now I want to solve for y, so I'm going to divide both sides by a negative 27. And y equals 2. So I have one of my ordered pair now. And if y is 2, I can use this equation up here. X minus negative 4 times negative 2 is a negative 8 equals a negative 8. I'm going to add 8 to both sides, and I get x equals 0. And you might say, oh, I can't have a 0. Absolutely, you can have a 0. This is okay. So your ordered pair now is 0, comma 2. This is your y-intercept here. And that's the place where these two equations would intersect. And we solve them through the elimination method, where we looked at the equations, modified one of the equations so that something could be eliminated, and then we solved for one letter, then used that in the other equation to solve for the other. All right, we have a few more to do. Again, if you don't have enough room in your regular lecture booklet, you can put this in your homework log. That would impress me. So I've copied these down correctly, and now I'm in the process of studying them. I want to do the easiest thing and try to keep the numbers a little bit smaller. They're easier to work with. So what will I multiply this by? And later, what would I multiply this by? So that something would cancel out. Well, if I multiplied this one by a 2 and this one by a negative 3, this would become 6x. This would become a negative 6x. So that's what I'm going to do. All right, let's see what you do when you get this next line here. Did you get something like this now? So here the 6x's cancel out. When I subtract a negative 27 from 12, I get a 15y. Add this up, I get a 30. Divide both sides by a negative 15, I get y equals 2. Negative 2. Now, how do I get what x is? Well, I can use my original equation up here, 3x. Now I know y is a negative 2, so 6 times negative 2 will be a negative 12, equals 3. So I get 3x equals 15. As I transpose that, becomes a positive 12. Divide both sides by 3, I get x equals 5. And there's my ordered pair, where they would intersect. Now, notice they are taking a little bit of time and study and creative work, a little bit of artistry here as you work these numbers. So letter E here is a little challenging. Here this is in standard form. This wasn't in standard form, so I had to bring that 16y over to put it in standard form as a negative 16y equals 24. Now as we study it, we're wondering what can we do to get one of these to cancel. Well, if I modify this equation by multiplying it by a negative 2, let's see what happens here. This will be a negative 12x, positive 16y equals a negative 16. And this one I'm just going to copy. This is 12x minus 16y equals 24. Notice what's happening here. This cancels out, and I get a 0 on this side, and I end up with a positive 8 when I add these together. Now, is this a true statement? No, this does not equal. When the letters are eliminated, this is a case where these equations are actually parallel lines and they will never intersect. So for this, there is no solution. Okay, let's look at letter F. We'll do this one together. Let's see what we have here. We have to put it in standard form. So negative 6x, negative 4y equals negative 2. Now I'm going to transpose this 18x over to this side, so it's a negative 18x. The negative 12y is already there, and we have a negative 6. So as we look at it, what can we do? Well, if I were to multiply, I'm going to get a different color here, this equation by a negative 3, that will make this a positive 18, and these would cancel out. So let's do that. This is going to be 18x plus 12y equals 6. Now I copy my bottom equation, negative 18x. That's what I was shooting for. Ooh, look what's happening here, though. When I add these up, this cancels out, this cancels out, that's a 0, this cancels out, and that's a 0. But does 0 equal 0? Yes, this is true. So, in fact, even though these equations looked different, they were actually the same equation. Because if I multiplied this equation by a positive 3, I would get exactly what's here in this equation. So what did we say when we have something like this? We put it in set builder notation, and that's our answer. Wow. Okay, this was rather long, but we hopefully did a good job, and you will be doing some practice. Remember, don't put this off. Give it your best shot now while you remember how to do it.